Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 22nd of the February daily Leetcode challenge and we have a hard question. If I remember correctly, this is going to be the first hard question of this whole month because I don't remember we have seen any hard question till now in this whole February month. Okay, and by the way, this is the second day for the trees series. Okay, from yesterday we started the series on trees and this is going to be the second day. Okay, and as I have predicted, as we approach the end of the month, we always have questions on graphs coming, graphs, trees, and DP. These are the very promising topics which Leetcode will try to bring during the end of the month, and obviously there will be some hard questions also in that. Okay, today is also one such question. So before starting this question, I just want to tell you, if you have first of all, I'm definitely assuming that you would have already gone to the question and you would have already tried it and then you are coming to this video. If you have not done that, always feel free to take the link of this question from my description, video description, go and see it what is happening once, and then maybe you can come back. Okay, because in this video I will always try to keep the content very short, because English videos I always try to make very short because I spend a lot of time and details in explaining in Hindi solutions. Okay, so okay, now there are two three aspects that I want to talk about before jumping to the code. See, first thing is that you are only given a string. Okay, you are not given anything else. You have to build the whole tree and then you have to return the root. Okay, that is the first aspect of this question. Second thing is that in this particular string you are basically given two informations. Okay, what are that? First thing is that the output in which you are the order of the output that you are saying is going to be a pre-order output. Okay, remember DFS. Okay, what that is depth first search. There are three ways to do the DFS. Okay, first one is the pre-order, second one is the in order, third one is the post order. Okay, so if you are not aware of these things, please do go and Google out them. See, these things are very easy to understand with a diagram. In Google you can get a lot of diagrams and you can understand that. Okay, it's just about the sequence. Okay, how we are reaching each node, that is what is different in each of them. Okay, so the current question that we are discussing, it is about pre-order traversal. Okay, so in this case, if you are seeing, there are two information given to you. First is the order in which the nodes are reached, that is the that is going to the pre-order traversal. Okay, you are given that sequence. Second thing is that for each node you are basically given the depth. Okay, so see, the technical term is going to be the level of the root. Okay, level of the node. So but they are calling as a depth. Okay, so if you see in front of two there is one dash, which means this two is in the depth of one. Okay, so as you can see, it is in the level number one. Similarly, before 3 and 4, if you see, there are two dashes, which means they are in the level number two. Okay, and so on. And obviously, since we know it's a pre-order traversal, so we know like this 3 and 4 should be like coming under which parent. Okay, so we know that. Okay, that's what is the information. So there are two informations. First is the order that is going to pre-order. Second thing is the depth for each node. Okay, these were given here. Okay, now one more aspect of this question is that I just want to tell you that, because so that you don't waste your time. Okay, designing a quality solution. See, always remember the example 1 and 2, they are showing only a single digit numbers. So your example 479 like that. But if you see in example number 3, you are going to get numbers around 401 also. Okay, so you have to design your code in such a way that when you're passing the string, you have to ensure that you are taking this whole thing at once. Okay, you should not take only 4 and something like that. You have to take the whole digit at once. So like, what could be the right approach? See, maybe let us your index for the index representing the number 4. So till the next dash comes, you have to keep processing. Okay, that's what you have to do. Okay, so if, by the way, if you see the constraints, each node value is going to be around 10 power 9. So there are going to be around, okay, 9 to 10 digits. Okay, so 10 power 2 means 3 digits, so it's 10 power 9, that means it will be around 10 digits. Okay, we have to process at once in the worst case. Okay, so each number can be around 10 digits, 9 to 10 digits, and that's what your code should be doing. Okay, it's not like going to be a single digit number always. They can be up to 9 to 10 digits of the number also. Okay, so you have to process all of them. So what should be the approach for each number? If you see, for example, you are in the index representing 4, from here you have to process all the numbers till the next dash comes. Okay, that's what your approach should be. Right, now how to solve this? So let me quickly show the solution that I have designed. And yep, let's quickly begin. So see, in my solution I'm going to use a DFS. Okay, remember, it's pre-order meets a DFS only, so please do not confuse between them. In question it is mentioned pre-order, I'm using DFS. DFS is implemented in three ways: pre-order, post-order, and in order. In this question we have the pre-order output, that's why we are also going to use the same. I will be, see, in the same sequence I will be going and I will be creating each of the nodes. Okay, let's quickly begin. So this is going to be my DFS function. Okay, and let me go through each aspect of it. Okay, first of all, like, these are the three global variables. What are they? See, first of all, for the input, I'm trying to capture its length. Okay, point number one. Secondly, I have two other variables. These are going to play a very important role in my whole calculation. See, this will tell me which current index I have to process. Okay, this is like before this diff is called. Okay, let's say I'm in the first line of the diff, so this index will tell me I'm at which node, I have to process which node. For example, let us say I'm at this particular index representing 4. That will tell me that I have to process this number now. Okay, that is a node representing this number. Okay, I have to process that. Okay, now this will tell me the current node that I'm going to process it at which level. Okay, for example, this 401, before coming to 401, I would have encountered a dash. Okay, this dash would have been already passed. Okay, so this the after this parsing, okay, after passing the number of dashes, the value will be stored in this particular variable. This variable tell me the next node that I'm going to that I'm going to create, or like I'm going to explore, it is at which level. Okay, this is for that. Okay, so I've explained both these points. Let us quickly dive into this now. Okay, so before that, see, the ideology is going to be, before we do the DFS of any, okay, any we can say node, then that node should be already created. Okay, that node should be already created. Okay, so in the like you can say in the stack in which the parent node explored, in that itself both the child node should be created if they are required. Okay, so this DFS function will not create a new node, it will only create child nodes. So just try to understand my ideology. This DFS function will only create child nodes. Okay, it will not create the parent node. Okay, the parent node should be already created before this function is called. So in this case, if you see, for the root, I'm creating the root and then I'm calling this function. Okay, let's see now what's happening. So if you see what is happening, first of all, I'm declaring all the variables as non-local, whichever we are referring from outside. Okay, next, first of all, I'm creating this variable called next non-digit index. Why I need that? See, for example, see, my this particular value next index will tell me that I am at this particular index. Okay, this particular index, right now. But I need to process the whole number, right? For that, I need to know when is the next dash coming. So if I know the next dash coming here, that means from my current index till the next dash comes, till then I can process all the numbers. Okay, for that reason, I need this. Okay, this next reason is going to tell me where is the next dash coming. So I will just use find function and then I will pass the next index, because from here we should start searching for the next dash. Okay, and then I will store it here. Let us say if this returns a -1, that means there is no dash coming after that. So the next non-digit is going to be n in that case. Okay, now this will be happening for the last value. Okay, for the last number, this particular if condition will be true. Okay, now what I'm doing, see, from next index I will go till the next non-digit index. Till then I will capture all the strings. Okay, let's the whole substring I will capture. That substring will convert to integer and that will be stored in root.val. Okay, yep. If you see at this point, when we are creating the root, it will be like a default value. Okay, if you see default value is 0, left is none and right is none. Okay, something like that will be happening. But after the defense function is called, we will come here and then we will assign the value. Okay? The value assigning is happening here. Okay, at this step. Now since I have now assigned the value, now my aim should be, for example, see, I have now implemented one. Okay, now my aim should be to implement the child node. Okay, as I mentioned, always in the defense function, the child node should be created. Okay, before calling the defense for the child node. So in this case, I have to process these nodes. Okay, as simple as that. So for that, now I'm going to the processing. So I'm doing current node level is equal to next level. So I'm just storing the current nodes level in this particular new variable. Okay, then this particular value is now assigning as 0 value, because now I have to find the level for the upcoming node. Okay, for that reason. Similarly, next index will now be as next non-digit index. Okay, now I will start the processing while next index is less than n. What I have to do, if I witness a dash, that means what I will do, I will increase the level. Remember, level is 0 currently, it will be increased. Okay, it will be increased, and then I will always also be doing next index plus 1 equal. Okay, I'm just incrementing next index. Okay, since it's a while loop, not a for loop. Okay, just being increment. Let us say, for example, see, this two dashes are processed and then I'm coming at 3. Okay, then I'm coming at 3. So when I'm at 3, what will happen? This next index, okay, this next index will be pointing to 3. Okay, this will be showing the index in which 3 is present. Okay, and then this if condition will be done. What is the else condition? This will be breaking out the loop. Okay, so we are breaking out. When we are breaking out, when we are at this particular 3. Okay, after processing the 2 dash, when we are at 3, this will be breaking out. At this point, next level will be showing the level of the next node and the next index. Okay, next index will be telling us at the index 3. Okay, as simple as that. Okay, what we are doing, see, if the next level is equal to current node level plus 1. Okay, that will mean that this particular, okay, for example, see, 401 is at level 1. Similarly, 349 is at level 2. That means it is just a plus 1 of the parent node. Okay, so if the next level is equal to current node level plus 1, that means the next node where we are going to process is going to be a child node of the current node. Okay, since it is going to the first child node, it will always be a left. Here they have clearly mentioned, if you see, if a node has a single child, that is going to be the left child. Okay, that's what we are trying to do. We will create a node for the, as I see, always I mentioned this at the starting itself. In the deface, we will not be creating the node. We will be creating the child nodes. Okay, not the root node. Okay, that's what we're doing. We're creating the child nodes for the current node. Okay, I'm creating the left node and then I'm calling the deface function for it. Okay, simple as that. Okay, similarly, once we come back from this deface function, what will again check if, for example, see, this you have to understand very keenly. This part I will say is the difficult part for you to understand if you are not good in imagining what is happening in recursion. See, first two will be processed, the subtree where the true two is the root, that will be processed, and then once we are at 5, at that point this code will be processed. Okay, so the number 2 that you are seeing will be processed using this code, the number 5 that you are seeing will be processed using this particular code. Okay, what it is doing the same thing. If the root, okay, root node level plus 1 is equal to next level, that means it is going to be our right subtrees node. So I'm just creating a new node and then I'm starting the device for that. Okay, as simple as that. And this is the where I'm calling this whole function. This whole function basically is called here. Okay, I'm creating a root node and then I'm passing it here. At last I'm returning the root node. Okay, So yep, this was the solution. I am sure that you will not have understood it, in detail. But what I will say is, go through the question. I will give this, whole solution in the comment section. Add some print statements. Go through it. I'm sure you will understand. Okay, because I've given all the explanations what is happening. But at this part, I'm sure you will not have understood, because for understanding this, you need a pen and paper. For the first time, if you are seeing this kind of code. Second thing is, you'll have to imagine how this is working. Okay, because see, between this statement and between this statement, there is a huge difference. Remember that when this statement executed, you are going to a new stack. A lot of processing is happening. For example, see, when you are at 2, you will process 3 and 4, and then you will come back to 1, and from 1 you will be, creating a node for 5. So there is huge processing happening between this code and this code. Remember that there is a huge processing happening. For example, let me tell you this fact. Let us tell you that. See, when this 2 is being processed, okay, we are at this code. Okay, when I'm executing this part, like the next index, the variable that was seeing at next index, okay, that is at here. Okay, but when I'm executing this code, what will happen? We are now at here. Okay, so this whole thing between 2 and this 4, okay, everything is processed. By the time we come from this to this, okay, this whole thing is happening. So that's what I'm trying to tell you. You will have to understand like how the recursion is functioning, how we are creating the nodes. But just remember one thing: the way in which nodes are assigned values is, we are going to follow this order only. We're also going to follow the, the pre-order traversals sequence only. Okay, the way the nodes are created, the values are assigned, it's going to follow the pre-order sequence only. So often that was all for this particular video. So I always try, see, I'm not spoon feeding. At the same time, I am not, giving a very inadequate content. I'm trying to, balance out. I'm giving you some hints, at the same time giving the code also. But still, I'm sure that, see, this video, you can just treat it as a, reference material. You can always get the code and you can submit it. But my aim is that you should develop the logic building. Okay, if you develop the logic building, if you understand how, what I am thinking while doing the code, that will act as an example for you in which you can also code. So my assumption is that after seeing this video, you will go and start coding, and then you will understand why this is working, why this is not working. Okay, and if you have any doubts, you can come back and see my code again. That's what you should be doing. Okay, please don't feel that everything should be taught in the same video. It's not like that. What I am trying is that I am trying to develop a logic building. I'm trying to teach you how this code works. What was my, ideology behind developing it in this way. Okay, as I mentioned, always before calling the deface function, the root should be created. Similarly, if you see inside the deface, we'll never create a, a node. We will only create child nodes. Okay, that's what I've done here. Okay, if you see, I've only created the child nodes. I've never created a node directly. The node should be created before calling the deface. Okay, as simple as that. Similarly, if you see, before calling the root dot left, the node is created. That's what is the ideology that I'm following. That's what I'm trying to teach you. Okay, so often that was all for this particular video. If you see, my solution is beating around 96 to 97% of the cases. Yep. So yep, if you want to follow this code, I will give you in the comment section and go through it and add some print statements and then try to discover what exactly is happening. But the sequence in which the nodes are processed is going to be the same. Okay. Yep. Like this. And if you talk about space and time complexity, see, we're only going through the thing only once. Okay. As simple as that. It's going to be open solution. And if we talk about space complexity, obviously we're creating a tree, right? We're creating a whole new tree. Obviously, every node is being inserted, no new nodes are being created. So obviously in space complexity it's going to be often. In terms of time complexity also, it's going to be often. And one more thing, they've clearly mentioned that it is going to be a binary tree. So see, normally what happens, DFS the space and time complexity, especially the time, they will say like O of n plus e, where e is the number of edges. Okay, that's for graphs, remember. But here, since it is a binary tree, that only going to be two child nodes. So e you can remove from that. So it's only going to O of n time complexity and often space complexity. So yeah, often that was all for this particular video. And this was my 123rd day. There are many more days to come for sure. If you like the quality of the content, if you feel this video could be useful for someone who do not have paid resources, then please do subscribe to the channel. This will give us a motivation to continue further. At the same time, the algorithm which LeetCode uses, which YouTube uses, will promote it further so that it goes to the people who cannot afford paid courses. For them, maybe like this video could be a good starting point to start their coding journey. So yeah, friend, that was all for this particular video. See you tomorrow. Thanks a lot.